Hello, good morning. Well, at least good morning here in California. My name is Aasman, and I'm the CEO of France Inc. And our core product that most of you know about is a knowledge graph tool called a Lego graph. And today, I'm going to talk about the last vestiges of dark data. So for a long time, well, most of the people in the audience know what dark data is. For a long time, it was just all the unstructured text, but there's actually even a bigger pool of dark data in the enterprise, and that is spoken conversations between customers and company representatives. And so today, I'm going to talk about how you can combine speech technology with knowledge graphs and about some of the things that we learned in the last 4 years that we've been deep into speech technology, NLP, and knowledge graphs. So personally, I worked in the late 90s, in the early 2000s at the Dutch telecom lab, and we were working on early versions of Siri and early versions of iPads, and I was writing articles about how, for example, on an iPad you could use speech input to write your emails and then use your pen to correct the mistakes that you made. And we were looking at systems like Siri, where we had a combination of human assistance and speech and assistance done by speech technology. And it was wonderful, wonderful work, but I was kind of always a little bit hesitant, and I never could believe that this could come to a real systems. Yeah. So, and even in 2014, that there were articles like this where people would say, well, speech recognition, the unreachable frontier. And here's an article by James Kendrick that says, voice input has been a pipe dream since Star Trek, with crew members talking into the air and the computers understanding every spoken word. And he claims speech technology can only do 95%, which I think he still was high. But be that as it may, my company, my customers are really happy with 95%. Yeah, because I mean, until recently, they had all that dark data, all these spoken conversations, and they couldn't do anything with it. But 95% is 95% more than they ever could do before, even infinitely more. So what I'm going to talk about today is what text analytics, NLP, knowledge graphs, and speech technology can do for your enterprise or your enterprise customer, right? And so, of course, a lot of you guys will be in the area of NLP and text analytics, and it's a booming market. Yeah, so they expect in 2024, text analytics is already close to a $9 billion industry, but speech is growing even faster. Yeah, I mean, Analytics Insights estimates that in 2025, the voice recognition market will be close to $31 billion. Yeah, and speech technology is becoming part of everyday life. I never would have imagined that we got to that point, but we have now gotten to that point. I'm a big fan of Google voice technology and their Google Assistant. I never ever type a text message. I always will say my text messages. I think Google is better than Siri, but people might disagree, obviously. And then, of course, a lot of you guys will already have an Alexa in your home, or you will use Cortana or Windows, or you will use something that IBM made, but it's become part of everyday life. Yeah. And it's not only that these big companies create those technologies, but they also provide APIs to it. Yeah. So here's a 2018 comparison where they look at what Amazon, Google, IBM, and all the others are doing. And I'll leave it in my presentation, but what you actually can see is that even now, the speech to text is good. Yeah? It's never get to the point where speech to text is excellent. So we have, for Amazon, speech to text is good. For Google, speech to text is intermediate. For IBM Watson, it's good. So it's getting there, yeah, these APIs. And one of the big problems, and I'm going to talk about it today, is that you really need to be able to customize if you want to create a service based on speech technology, you'll find that there's a lot of domain words that these speech recognizers don't do yet. I mean, they're getting better at day over day, but you need to be able to customize them. And that is where right now the biggest problem is with using these technologies. But I'll talk about it today. Yeah. And so, say you're working for a big enterprise, or a big enterprise is your customer, yeah? What can you do with spoken conversations? Well, if you look at what people now do with NLP, it's mostly focused on regular text and documents. But believe me, practices for text analytics on documents cannot directly be applied to spoken conversations. We find that normal human conversations are so informal, yeah, that it just won't work. Yeah, so we had to work for the last 4 years to really see what NLP techniques we efficiently and effectively could use for spoken combinations. And so today I will discuss a use case that we did, or that we do, with an intelligent call center. The call center that we work with is a company in Atlanta called N3 Results. They have about 1,500 call center operators. We call them BDRs. Nearly all of these people have a college degree, so it's an intelligent call center and a high-end call center in the sense that they don't do just simple scripts, the people that call you every day, and in most cases just following a dumb script. Now, these people, before they make a phone call, they first will investigate the person, the company, and then, only then, will they do a call. So it's more expensive, but it's high end. And in order to get better at this, they have been developing a lot of AI, and we're happy that we could help with that. And so they got to the point that then Accenture took them over 2 months ago. All right, so this is the call center company that we work for. And so we have a knowledge graph for this call center company that is mostly based on just structured data. Yeah, so you want to build a knowledge graph for your call center, whether it's CRM, sales calls, or technical support. I mean, what are the things that you want to record and what you can learn just by looking at the structured data in your CRM databases and all the other systems that keep track of what's going on in your call center? Well, you want to know what companies and individuals did I talk to before, and who's the best person to talk to, and what did I learn about that company or the person in my call. That's right, and you hope that your people will make good notes. And is that person that I talked to still working for that company? Maybe I have to go to LinkedIn. Which of my salespeople made the most sales and why? Or what sales agent is more effective for what technology or what kind of service, et cetera, et cetera. So you can imagine there's a lot of things that you can put in your knowledge graph to make your sales processes better. And so here is a picture of a little part of the knowledge graph. We call it the corporate memory knowledge graph, yeah, that can answer a lot of the questions that I just showed you in that slide. And this is a picture of Graph, which is our visualization tool on top of a Lego graph. And here you see that N3 might have a client, like Rocket Cloud Services or DigitalOcean Cloud Services. And then when you have a client, you do multiple campaigns for the same client to focus on one particular element that you want to sell in this particular campaign. And then you will have these sales agents here that work for a campaign, but obviously they work for multiple campaigns and they have a start time and an end time. So we kind of note when people started working for the campaign and when they stopped working. And then on the other end, you have the customers that you try to call. You have, just for fun, CVS Oakland or Acme Bread. And then you have contact people that initially worked for this company here and now work for this company here. And we know a little bit about the company and what they sell and what technology they already have. Yeah, and then there are the events between the call center agents and the customers. Yeah, and these are the core events, the emails that get sent and the voice calls, right? So you can imagine this is a kind of an impressionistic view of our knowledge graph. But what we found out that, okay, there's already billions of triples just in the structured data, but the real interesting data is in the voice calls, yeah, or in the emails between call center agents and contact persons that work for companies. Yeah, so this is where all the magic happens. So what do you have to do to get the interesting data out of these voice calls? Well, you need to do speech technology, yeah, And then once you do that, what you really want is to help the call center agents in real time. Yeah, so there's this dream of real-time decision support. Yeah, for example, where is a particular agent in the sales cycle? Yeah, did she move the process forward? And so one of the things that you'll see several times is the word BAND, which stands for budget, authority, need, and timeline. Yeah, so what you really want is that your sales agent makes sure that before you hand off a particular customer that you talk to your big client that will finalize the sale, for example, that you really know that the person you talk to has a budget, yeah, can make a decision, actually said that he needs something, and knows when he needs it, right? Okay, so that is just one thing that you can help the sales agent, like, hey, you didn't talk about the budget yet, please ask about that. Then, and these are all common sense things, but should I correct for open and closed questions? We find that certain call center agents talk way more about product categories, whereas others talk more about sellable products. And we find that usually it's better to talk about products that you can actually buy. Yeah. Or how can you help a call center agent when your customer talks about a competitive product? What you really want is when this competitive product is mentioned, that you provide a battle card in real time. Yeah, a battle card is a card that gives you the main arguments against your competitive product. Or it's also very important that if you talk to a customer, that you know in what industry he is, yeah, and what job title, and what his main use case is. Again, if you don't know that, then your sales call is kind of useless. So you need to know all these things. So we help with that too. And sometimes you even want to do real-time routing. If you see that a customer wants to know about video conferencing, well, maybe Joe knows more about it and just switch while you're in the call. All right, so these are just part of the dream of real-time decision support. But then if you analyze the voice calls, you also can do regular analytics that you never could do before. Yeah. So for example, what are the features and functions that the customer talks about the most? Yeah. Or do we see that there's momentum for a particular product that whether it's your own product that you're trying to sell or a competitor product? Yeah. And if the customer talks about a particular type of product, what is the sentiment? Or why is agent X so good at selling product Y and way better than any other of the agents? And again, there's a lot of analytics, and this is just a few of the tens and tens of kind of analytics that we do on top of the calls. All right, so now, so we have the speech technology, and I'll give a demo in a few minutes, but all of this is based on our architecture for how we deal with speech and text in our Allegro Graph knowledge graph platform. So we can deal with any kind of input. Yeah. So obviously we can deal with regular text that you find in an email, chat, etc. We do a lot of work with documents where we use, and we can take any kind of documents and then use a tool called Apache Tika to turn it into XML and turn it into smaller pieces. Or we use voice to text, and we ingest it in Allegro Graph. And so now we have fragments of text in our database, but they're just unenriched, just dumb pieces of text. Now, if you want to analyze that text, you obviously need a taxonomy. So say you're trying to sell a product around sustainability, well, then you better have a taxonomy, yeah, that knows all the important words related to sustainability. Or if you're selling a particular product for one of your clients, well, you better have every product that the sales agent or the customer talk about and have that in your taxonomy with the pref labels and the alt labels and the whole hierarchy of important concepts in your data. Yeah, so we work with tools like Smart Logic or Pool Party to create these taxonomies. We export the taxonomies in Allegro Graph, and now we can go to work, right? So we can take the taxonomy and text fragments, give it to our entity extractor, and put the entities back into the knowledge graph, and that way enrich the text. Now we have our own internal entity extractor in Allegro Graph because we deal with very complicated product names, and there's not a single entity extractor on the market that is really good at it, unless you provide every alt label that you can imagine for a particular product. But we found that for product names, it's better to just have your own heuristic entity extractor, so that you don't have to provide all these alt labels. Anyway, that is, so we can use external entity extractors, and we have our own. Then obviously you want to have the sentiment in the text. So we have a sentiment analyzer, and we add sentiment back to the text. Sometimes you want to know what kind of conversation you're in. For example, you have a conversation and you want to know, is this a direct sales? Or is this a request for technical help? Or does the customer want to replace all their technology that they already have, or just want to optimize it, etc., etc. So we do a lot of work where we label conversations, partly automatic, partly by using humans in the loop. Yeah. And once we have the labels added to conversations, we give that to our own text classifier. We have our own internal one, but you can use external ones if you want to. Yeah. And we even put the classification model in the knowledge graph itself. So the classifier becomes part of the knowledge graph. And now when we're in a new conversation and someone starts to talk, within a few sentences, we already know what kind of conversation this is, and we can start giving real-time help to the call center agents. Then another important part is that you really want to know, especially when you build recommendation engines, is what are the terms that are usually used together with other terms. So we do a lot of work on co-occurrence, correlations, odd ratios between terms, and we use that for our recommendations and other things. And once you've done all of that, then the fun can start, and you can do semantic search and semantic exploration. You can apply your analytics, and you can do ad hoc queries, or you can provide real-time decision support. So this is kind of a little overview. This is kind of an overview of our system. All right, so, but I promised to talk a little bit more about our taxonomy-trained speech recognizer. So, as I said before, one of the problems with the commercial speech recognizers that you can buy, or get a subscription for, is that they're really good at regular language, but fail at product names, and regular names. So what you really want is a speech recognizer that you can train from a taxonomy. So that's what we did. We took, we created several tools where we can take an existing taxonomy with the pref labels and the alt labels, use that to train the speech recognizer, and then when you get the transcription from your speech recognizer, you'll find that the quality of the text output is way better. That makes it that the entity extractor is way better, and the output of your entities, and so the whole quality gets better by having a taxonomy trained speech recognizer. So that is the thing that we specialize in. So here is a little demo of that. Let me see if I have a better version of that. So, for example, after every sales call that people do, they are required to fill in a summary of what they talked about with the customer. We call that a note-taking app. And in that note-taking app, we want to know, okay, what products were mentioned, were the competitors mentioned, what's the job title, did people talk about the band categories that I talked about before. And so let's see if I can find this here. Yeah, here. So here we have someone that uses this little application. Let me see how that goes.
So I talked to Bob Johnson. He's the VP of engineering for the subatomic division. He said they want to buy some routers, and specifically they consider Cisco RV215W and Jupiter CTP 2056.
Jan, we can't really hear the audio.
Okay, so basically, yeah. Okay, let me just. then do this. We trained this beforehand. Let me just explain what happened. Yeah. So basically, this is a person talking to this application to give a summary of what was talked about, and the output of and what you saw here move around is the same thing you see on your phone. As while you're talking to your phone, you see that the speech recognizer is making corrections on the fly to get better interpretations. But what we then do is we take out the entities that are important to us, like the products mentioned, the competitors, the job title, and the band title. So let me go here and go back to my presentation. Yeah. But the important thing is that once we're done with this conversation, the entire conversation will be instantly in our knowledge graph. So what you see here is, for this particular little session that you just saw, and I'm sorry that the speech quality wasn't better, we see that there was this particular session. There's a bunch of phrases in this session. One of them was, so I talked to Bob Johnson, he's a VP of engineering, and this is the text fragment, and then here is the result of entity extraction, and we found that, okay, there was a job title in this particular phrase, it's VP of engineering, which has a broader contact person. So these are terms that come from a taxonomy. And here we see that there's another phrase, and here was about some of the technologies, and we'll find that in this particular phrase, we then found the Jupyter routers. Well, anyway, as you can see, various products. So within a second after you're done talking, it's already part of your knowledge graph, and you can do analytics on top of that. Now, what did we learn during these last 4 years that we've been specializing on speech technology and NLP with knowledge graphs? So the first thing that I already talked about is that most speech-to-text systems fail on very specific domain words, yeah, whether it's product names, medical terms, financial terms, etc. And the customization is in its infancy. So what you really need is get really good at customization in a very short amount of time. Because our customer gets a new campaign and they can't wait weeks to train a new model. They want to start working the next day. So we spend a lot of time on the customization processes. And for static domains, we can train language models, but we also use speech-to-text systems that allow you to train using phonetics. So that's a very important one. Then in the audience, there are undoubtedly people that built their own taxonomies, but I can tell you that building the alt labels for terms that you normally do for text is really, really different than when you do it for spoken conversations. Yeah, the sales agent will say Cat 9K instead of Cisco Catalyst 9000L, right? So it's a lot of work for us to get this done. And then there's the issue with numbering, just a simple issue, but the word 9121 or 9121, yeah, or 9121. There's so many ways that people can say these numbers. So you need to deal with that. Then it's pretty hard that it's a problem that, especially with short words, yeah, they overlap too often with the regular English terms. So we spend a lot of time on making sure that we actually get the right word when we train the systems. And then there's all these little tricks that you learn, like don't put the client name before every product name. So in a Cisco catalog, every word is prefaced by the word Cisco. But the problem is that if you do that also in your when you train your speech recognizer, that the thing becomes way too greedy, yeah, and all the words become Cisco. So you don't want to do that thing. So anyway, and this is just a few things. I mean, there's literally hundreds of little things that you learn when you try to train these systems in a very fast way. And we actually wrote an application just to deal with numbers and product names to create a proposal for phonetics. And you can contact me later on how we do that. Then lesson 3 is you need a speech recognition system, a speech recognizer that provides both real-time and batch processing, obviously. If you want to do real-time decision support, you better do real-time processing. One of the issues is when you saw my demo, you saw that the speech recognizer was correcting itself all the time. Yeah. So one of the big questions is how long can you wait till you trust the transcription? And obviously, for For some things, you don't need to do real-time processing. Batch processing is good enough. But not all speech recognizers are really good at real-time decision support. Then another thing is, we as human beings are really good at separating who is talking, who is saying what, right? But it's still an active area of research, yeah, to do it for, say, spoken conversations where you don't have any visual help, yeah? And it's very important because what we find is initially we were just taking a transcription of both the agent and the customers at the same time, but the results weren't that valuable. What really makes a difference is if you can split what the customer is saying about a product, a competitor, etc., and what the agent is saying. Yeah, and so right now we don't trust the speech recognition systems too much to tell you who's speaking, but we try to do it at the level of the telephone routers. But the problem with the telephone routers is that it's also fairly new to all of them, because they were always used. Well, they were built for regular human-to-human conversations and not to help speech recognition systems. So again, this is all fairly new and exciting research. Then some speech recognizers. So the other thing is so speech recognizers make mistakes, right? So you get a transcription back. But some speech recognizers give you for a phrase or a word multiple interpretations. So then in your entity recognizer or phrase recognizer, you can still do a lot of post-processing, yeah? And so again, if you want to choose a speech recognizer, you better get one that gives you multiple interpretations of a word. And then how well does your speech recognizer with other languages? And are they all of the same quality? Well, some of you live in the world of text analytics, and you probably know that even if you just do NLP on static text, yeah, there's a difference in the quality of the languages, even within the same product. Yeah, the product might be really, really good for English, but then way worse for, say, Korean. Yeah, maybe because for English they use WordNet internally, but for Korean they only use lists of words. Yeah, so you get different. Well, in speech recognition system, it's even more pronounced. Yeah. So when you look at the speech recognition system, you also want to look at how good are they for multiple dialects of English or Spanish. And some of them are starting to specialize to kind of recognize almost all kinds of English or all kinds of Spanish. And some of them only do one dialect. So, and then on top of all of this, if you, like we do, work on creating speech recognition systems for multiple languages, well, it's a huge problem that if the people that work for you don't speak all these languages. So that's a little additional problem that you might want to deal with. Then quality control. So we learned that automated testing is like, well, everywhere. It's very important. So we have for every campaign and for every language a gold standard conversation, and then we run it every X minutes to see if the right words and the phrases come back. And we also found that you can't do it without a human in the loop, because if you train a speech recognizer on your taxonomies, some of the regular English or any other language deteriorates, and only a human can detect that. So we try to avoid, sorry, now I'm going too fast. Yeah. So only a human can detect that. So we always have a human being that at least does some quality control to see where we are. And what this person actually most looks at is to avoid false positives. Yeah, we don't want to tell our customer that in conversations a particular product was mentioned too many times. We rather not recognize the term and miss some words than that we tell the customer that there are too many of a particular word recognized. And again, you need automated testing and a human in the loop to deal with that. All right, so concluding, if you want to do a speech technology project, we are really happy to help and help you to incorporate the output of speech technology in your knowledge graphs, because there's really some amazing business benefits in all of that. And it's really, really fun to do. So thank you for your attention, and maybe there are some questions.
Thank you for your talk. It was great, as usual, I should say. We have one question here in the chat about how you combine speech analytics and EU GDPR regulations. How is that working together?
Well, the same kind of applies in the United States too. Some states allow you to record conversations with permission. Some states allow you to record without permission. But in a country like Germany, nothing is allowed. Yeah. But the laws have not been yet really defined for listening in using speech technology, right? So it is not. So you are allowed to listen in with an automated system and extract the most important words out of a text. There's no one, I haven't seen yet anyone that would forbid you to do that. Although, of course, the GDPR still completely applies, because even if you get elements out of a conversation, that's coupled to a particular customer, and that customer, of course, is under the GDPR. So if you want to forget about it, then you have to be able to forget. But remember, when I showed you my picture of our knowledge graph, we do have, because we have this knowledge graph, we actually know every word that every customer ever uttered, right? So we actually have a system where we can forget, yeah, because we have completely documented. But it's a very complicated topic for call center, really, really complicated.
Another question from Frederick Landvis. Did you acquire foundational taxonomies to jumpstart the training, or have you incorporated open vocabularies in your system?
Yeah, actually, so one of the fears of any customer is that they have to do all the taxonomy development all the way from the start. Yeah, and so we use at N3 used WAND technology. There's a company called WAND, W-A-N-D, yeah, that provides some foundation taxonomies, and so you can start with those, and then you can expand. These WAND taxonomies don't have many alt labels, but at least it's always a great start of the core hierarchy that applies in a particular domain.